Okay, good evening, everyone. This is IoT Toolchain BoF. My name is Maxim. I'm from Linaro's Toolchain Working Group. I'll be hosting this, and I welcome anyone else who wants to contribute or speak or present their view to just raise their hand or come on stage and join me. I will not pretend I know anything about IoT. This session is mostly to gather requirements for what an Internet of Things toolchain can look like. Whether it is the same as embedded toolchain or not, what tools IoT developers need, what targets they use, what targets they develop for. So anyone else is interested in joining me is here on stage. Lovely.
They can be very shy, Maxim. The fact they're here at all is a bit of a battle won. So.
Okay, this is the place where you want to ask your questions and give answers. Here we can chat, and the ultimate goal is to figure out whether we need to do anything inside Linaro for IoT toolchain, or whether IoT developers already have everything they need to do their work productively.
I've started the document for some notes so that you can just do what you do.
Okay.
Quick question. I'm going to ask a question about IoT. Sorry, I'm breaking my own rules. Thank you very much. What's the scope here? Is it compilers, big tools, little tools?
It's starting from compilers up, so whatever IoT developer uses throughout the day, possibly with exception of IDE.
Right, okay.
Maybe including IDE. So lower level tools stay IDE, and we can look at IDE as just a combination and user-friendly interface to the tools.
Okay, no, thanks.
Yeah.
It has to be something we can work on.
Yeah.
I wouldn't expect you were. I was just trying to, is it, based
Compile.
Combination tools where you can trace lots of things.
Yeah, so assemblers, linkers, compilers, profilers, libraries, debuggers, of course, yes. Tracing, possibly emulators.
Tracing tools. Coverage.
Yeah. Tracing and coverage.
Can I make a first comment?
Yeah.
It's on? Okay. Just to warm the room. You said toolchain, singular.
Good one.
Because if we have so many RTOSes in the IoT space, we have some experience in integrating a toolchain for a given RTOS. Generally, you have always.
Generally, you have horrible headers with it, this, that, the other, depending on the tools, because they're all a bit brain dead and don't work like GCC. Right?
You have some adaptation to do to your toolchain, because it's not the same way to make the toolchain work for, I don't know, FreeRTOS. FreeRTOS is almost nothing, but each time you have some adaptation for. You see my point?
So let me give my opinion on this, and then you can say whether I answer your comment. When we discussed this in TCWG, what a toolchain for very, very embedded and a small device should look like, one thing we all agreed on was that it should not be a single toolchain, that whatever operating system, Zephyr, or any other platform Linaro should be working on, it should support a minimum of 2 toolchains. Not because we care that much about GC or care that much about LLVM, but to make it possible to prevent lock into a single toolchain. in the project. So when you ask why the slide says IoT toolchain, it should actually says IoT toolchains, because we don't want to have a single IoT toolchain based on one technology. We want several of them out there so that developers can easily migrate their RTOSs and their applications and their implementations from one toolchain to the other. Does this answer your comment, or is it about something else?
Yes, I agree with you. So it could be the same compiler and different profiles for the libraries, for instance, because we see that in the library integration where you will have adaptation to do. If you use Newlib or Muscle C or whatever, if you want to support semi-hosting, for instance, you have also adaptation to do. If you want to have multi-threaded, if you have an RTOS that supports multi-threading, same thing, you have adaptation. So it could be the same compiler, but integrated in various combination of tools, I would say.
So yeah, I was just about to ask whether Renato has a comment.
So I do. The first thing Maxim said, two toolchains, is important because we just seen in the AOSP toolchain that they're now using Clang exclusively for Android, and they have already introduced LLVM-specific behavior on Android. And that is exactly why that's actually the opposite of why we wanted LLVM to be on Android. It was to make it possible for two toolchains so the code would be better rather than LLVM-specific. So we want to be looking at different options all the time and stressing that point. But I think what you say is slightly different is you have specific requirements that are not necessarily visible to Linaro. So there's two ways we can do this. Either we have a member engineer that does something for your needs, or we can do all the way up to the open source store and then you use the remaining. So with LLVM it's easier to do that because we can commit upstream patches or we can introduce upstream changes that are not necessarily visibly beneficial to everyone in the LLVM, but because it's beneficial to downstream users, they accept it as a good thing to have, right? In GCC, it's harder to do that kind of thing. So, I mean, you just have to see what balance do you want, and this is anyone in the room is, and how much we can actually do about it, because I mean, if you have one target and then we have to implement this whole thing in upstream just so that your target is easier to maintain, that will be a huge effort. That, for instance, if you have like a member engineer to do that, fine, we can take lead and make sure that it goes upstream.
What you're talking about is where you've got an RTOS that's being built by a toolchain and you would like it to be built by LLVM or GCC. So there may be a bunch of
No, that's the one side.
Yeah, that's one.
Yeah. The other side is when you have an RTOS that is built partly by GCC and partly by their own toolchain because the linker scripts are different and whatever. So how far does the open source technology goes before it's actually proprietary or secretive?
So, you know, the TI-RTOS product today ships, and the kernel supports building with the TI proprietary toolchain, which is no cost to customers. It ships with the ARM embedded teams, GCC, and it ships capable of building with IAR. Customer number one toolchain is IAR, and you know, in our market, you can't claim to be an RTOS if it doesn't build with IAR, and then the number two is the TI proprietary one, and very distant third is GCC. Why GCC is the main problems with using GCC. There's some compiler stuff. But it's mostly the runtime library and the linker. And, you know, our compiler team may think there's TI differentiation in our linker, but we would quite happily have, you know, as a company, have all that stuff upstream. Our C runtime library is already BSD licensed anyway. So it's not like we're holding this stuff back. It's just that the open source toolchain isn't there yet for truly embedded targets.
Yes, and that is the question. I mean, how much of that can we common up between the different vendors and say, look, you guys are solving the same problem twice. And you're already BSD, he may already have BSD as well, but it's a completely different library. And then how can you adapt your products to his libraries or vice versa? You can't. So there will always be the cost of getting those things working together. So you already have 3 toolchains, you don't need another one, right? So what he said, toolchains, is not necessarily GCC and LLVM plus whatever else you have. No, it's at least 2. And you already have 3, so that's more than enough. So we're not trying to add more CRUD into your...
So my point is the same as, so you guys started talking about, it's all about GCC, but in the real embedded world, almost no one uses GCC. It's either IR, I thought it was Kio in terms of the compiler. And they always come with the microcontroller anyway, so I don't see that as a potential problem for the IoT guys. So I think there are two issues. One is for the system guys, what's the tool chain to use? And then for the application developer, what would be the tool chain we want to build that hopefully enable everyone to build on top of the different kernel or whatever. I think that's the issue. So not so much I think it's the compiler, it's the library. In the embedded world, most people say, oh, I can use, once I use GCC and they put in glib, I'm done. The glibc is too big, right? So there's the different version of the different miniaturized version of C library. And that's, if we can somehow get a standard on that, I think that will help a lot of people.
So I don't think anybody would use glibc in the embedded world. The question is really whether newlib is up to it. And if not, why not, and what can be done about that?
I sent in slides, but so I think it'd be great to do some really small builds and do the comparison. A lot of it is just, you know, for the RTOS model, we need the TLS model, right? And so in newlib, that means they have 3 or 4 different ways to do the reentrancy requirements. Zephyr uses one, TI-RTOS uses another, the ARM embedded GCC group uses another. So first off, everybody's choosing a different choice. And none of them are that great because they replicate a whole bunch of stuff that doesn't really need to be per thread. And so that's part of the problem. Do you have any other concrete examples for newlib?
Yeah, no, I can't. So yeah, and I think so. The other aspect about the code, right? So if you look at EABI, you could just work at the object level and just have a common runtime library and a common linker, but then there's all the stuff when I actually have my source code and compile it. So in terms of just the portability of your source code, right? Many of the embedded guys aren't writing portable C code, and so you have to also, you have to worry about the source code, not just the object code being portable as well. So, for example, with Zephyr, what's the approach to writing your code so it can be made portable across compilers?
But that's the benefit of using multiple compilers. Because once you start using GCC, then you know at least what GCC accepts, which will be different than whatever compilers you got used. And then at least you say, oh, wait a minute, you know, this is not portable. So at least that gives you the dynamics of how many things you're going to have to change in the source side.
Yeah.
Most people are not starting with GCC, they're starting with IAR.
No, that's why I say use GCC to see what they have done that is IAR specific.
To build your product with IAR, but test with GCC to make sure it works.
This is exactly what people done with GCC versus LLVM. You know, in Zephyr there's an LLVM build, and it's not to make it work. It doesn't work. I tried it. It's to just get the error messages and the warning messages, and that's it. That's the only thing they do is to compile. It doesn't even need to produce object files. It's just the warning messages they are after. And that's great. I mean, I don't really care if they use it or not. I mean, if there is potential, if there is something that is good, you get the warnings for free. Good. And that's a different, but the libraries, I think, is the important thing. Do you think all IoT vendors could common up a library that is not in new lib, is not, what's the other one?
Well, I don't know if
Muscle.
new lib is unfixable. And I think, we have code that we can contribute, but
Do you have patches to new lib or?
no.
No,
So
okay.
we have a complete C runtime library, but we could, take pieces out of it and contribute it to new lib or something.
I think the biggest impediment to changing new lib is its need that it support wine. It supports wine. One of the main set of maintainers are the guys who use it for wine, and they don't want to change anything that will break their backwards compatibility ABI. Now the rest of the world doing embedded doesn't care about that. They would happily toss half of that out tomorrow if it made the library smaller or more appropriate. But the wine guys need a compatibility story.
So newer lib.
Newer lib, yeah.
So my understanding of this conversation is that you're looking after a tool chain that, or a standard that the source code can be migrated among different tool chains. Well, the embed GCC was never designed to be source level compatible to other compilers, except the LVM, because those two are quite close. But in terms of IAR, in terms of TI's internal compiler, or even ARM's embedded compiler, they were not designed to be source level compatible, but they are designed to be binary level compatible or object level compatible. So looks like the requirement is have a totally new mindset of IoT toolchain, so that the source code can be portable among different toolchains, something like that.
Techniques to handle multiple compilers is not that challenging. It just takes discipline, right?
Yeah.
You need to.
Well, and cooperation.
Yeah, I mean, but you need the right set of abstract macros or pound defines or something, and then it doesn't percolate through your whole code base. It's contained, right? So.
Well, the CMCs helped at certain level. I think CMCs help at least to consolidate the microcontroller HAL level, but in terms of but if you rewrite in the CMC's way, then it helps a little. Well, if we're pushing for a new standard or
Well,
something,
but
then
this
we'll
is an
have to
RTOS level problem, so don't
Yeah.
try to solve it with the tool chain.
Yeah, of course.
So,
Yeah, it's
and
not a tool chain,
there's
yeah.
many example RTOSs out there that already do this today, right? So,
Is there actually a set of goals for what you want the IoT toolchain to be? It sounds like you might be starting off the gate being way too ambitious.
So that's coming up in the discussion. So that's one of the upcoming points. Christian, you had a comment?
Yeah, I just wanted to know, today Linaro is developing Zephyr.
Yeah.
And what have we discovered in terms of the kind of runtime we need? What are we using for building Linaro and for building Zephyr? Not Linaro, Zephyr, sorry. And for building Zephyr application, which library are we using?
So Zephyr has two models. They throw away newlib and write their own minimal C library right in the Zephyr code. And then you can throw a pound define that takes that out and brings in newlib. And that never gets tested in Zephyr as far as I can tell.
Specific new lib, or it can be any other C?
No, it's newlib.
Right. That's
But they make a different assumption about what the reentrancy model is than what everybody else seems to think is a good choice. So, there's adaptation. So, I mean, that's one of the proof points that newlib isn't sufficient right now, is because they chose to throw it out completely and rewrite it a super minimal one and have two modes, right?
Should we be careful about our terms in some respects, like when we're talking about things like
newlib and say libc and some of our other C libraries, there's the C standard part of the library, which should be fairly portable across platforms. But then there's the sort of runtime startup code. There's the different, there's different extra aspects.
That's the problem.
Yeah.
So you have the 15 on ZC, 15 or more standard, which are the language support for C, and the rest is really OS dependent, and it's completely different from the glibc in the glibc or in newlib, okay? Because it's OS dependent.
Which standards? It's C99, C11?
Right.
Which subsets, which annexes?
Yes.
So, JerryScript's another example where they have their own libc and libm that comes with JerryScript.
Dare I mention C++?
No, it's all C code.
Not yet.
Yeah.
So if in the IoT space embraced by Linaro, we have, I don't know, 1, 2, 3 OS, RTOS, maybe we should concentrate or focus on the tool set for these RTOSes.
I think we only have Zephyr.
Yes, only Zephyr and
Because it's not possible to take care of all the toolchain used in the IoT space. I think it's impossible.
Yeah.
Especially commercial ones that have their own debugging format. The debugger is let's.
so,
Yeah.
Well, it's easy enough for a vendor to say, you know, to use a different tool chain, and I'm going to add these extensions, and suddenly it's proprietary.
So there is a
and, yeah.
standard, but it's extended in a proprietary
Well,
way.
yeah, I mean, the standard is essentially Dwarf 3,
Yeah, okay,
but, you know, GCC uses Dwarf 5 now, so...
But think about OS awareness. If your debugger's got built-in visibility of your OS.
Yeah,
so
awareness in the IoT toolchain, for instance.
yeah, so it sounds like the fragmentation of the different platform. So one thing I think we need is something like the compiler farm or something, so that if I modify a line of code, so I'm able to test on other different targets. Yeah, because I think the major reason why the people duplicate the code is I'm unable to test it on other platforms. No?
yeah, that's true.
It's intended.
It was to reduce size of the minimal build,
Okay.
because the minimal build in newlib is
Because you can't
carries
take
a lot
the
of
standard,
carries
so
some
you
load.
could make the standard bit smaller too.
And another comment about the RTOS awareness things. So nowadays in the OpenOCD, which is a JTAG debugger, so they have, for each RTOS, they have their own copy of the implementation or the interpretation of the threads for that specific RTOS. That is painful for the OpenOCD maintainer to maintain this code. So that is another problem.
Okay, so we have been discussing various RTOSes and various tool chains so far. And runtime, yeah. So what I'm interested in is what is your opinion whether IoT toolchain is the same as embedded toolchain? Whether there are tasks and sites to IoT development that are not exercised in embedded toolchain, in embedded development.
Yeah, define embedded. What's your definition of the embedded toolchain?
See, IoT plus
So
something else.
we have a definition of embedded toolchain, right? Because this is a toolchain for, if we speak about ARM, Cortex-M or Cortex-R, with a small C library like newlib or musl, and with a compiler, whether LLVM-based, GNU-based, Keel, AR, and so on.
But we have customers who use Cortex-A cores in bare metal mode. Huh?
So that's bare metal, that's not necessarily embedded.
Yeah, but it's to say that Cortex-A doesn't immediately means Linux. That's the point.
Yeah. So probably very helpful if you go to your last page. I think that's what you mean by the embedded toolchain. It specifically means the toolchain that ARM's been releasing. It has the architecture support for the latest Cortex-M, Cortex-R CPUs, and it has new lib, GDB, GCC, and the bin utils. And it also has a little bit of A profile support. So really the question is, do people think that toolchain is enough for IoT? If it's not, what is missing and what need to be done in addition, or either in addition or change to a new toolchain?
So it's a start, but it doesn't have RTOS awareness, right? Which is what everyone here is saying, right? Is you have to have a tool chain that is RTOS aware, and that also needs to expand to solve, one of the problems that does exist today, not just the OpenOCD having to be, the maintainership of what OpenOCD needs to know to be RTOS aware, but then there's 1,001 forks of OpenOCD on all across all these different SoCs on ARM, it's a mess, right? We want to be able to get to, or desirably having an OpenOCD that does support, a plethora of vendors, as opposed to every vendor having to go find, some vendor or somebody who's got hacked support for that vendor's SOC somewhere, right? Like, that's just a mess today. So that's definitely something that should be cleaned up as part of the IoT toolchain.
At the risk of playing devil's advocate, can you define RTOS awareness in a generic way so that we can actually build something into the tools that's truly agnostic to the RTOS?
No, because that's the whole point. It's
well,
not,
exactly. So what you're saying is the tools haven't got RTOS awareness, but now you're saying that actually it has to be RTOS specific.
Yeah, correct. So I'm not sure what you're
asking. Well, the point is then you don't have a generic toolchain. You've got a custom toolchain.
So the runtime library, yes. The debugger, no. The debugger interfaces could be modular so that an RTOS-aware module could be plugged in.
So I mean, this is what really we need to do is abstract these things down into things that we can build into the tools, and then we leave the bits that they can't be in a more extensible manner. But until we can do that, essentially we're going to be forced back into the same position as we're in today. Is everybody needs a custom toolchain.
So about the RTOS awareness in GDB plus OpenOCD, that means OpenOCD is aware of the thread in that RTOS. So that is a fact in the OpenOCD. Yeah. So I'm not means that is a definition of the RTOS awareness, but that is a fact in
I just would like to clarify one thing, because I heard that the IoT toolchain means there is an RTOS, but in the future, won't we have IoT devices that run bare metal application? We will have always an RTOS. It seems that in the discussion we are saying that embedded toolchain or IoT toolchain means RTOS. Yeah, I agree with you.
So
prefer this one.
One of the aspects of IoT is that it is connected, and implementing a whole either Bluetooth or Wi-Fi or IPv something stack in a bare metal application is significantly more difficult than using an RTOS.
Yeah.
So I think it's one tool chain with two modes. There's true bare metal, and there's bare metal with TLS, thread level storage. Because some of our OSs really rely on thread level storage to get the job done. And then you can have a consistent, you can write code just like you do in the Linux user space, port it over to the RTOS. I mean, not every API, not every library, but you can write code that for execution on the MCU and actually run it in Linux, and it just works, right? So And, you know, this is the story that we push in TI-RTOS, and we do it with TI-RTOS and FreeRTOS. And we hope to do it with Zephyr as well.
And is it something that the toolchain can help in, it comes to the TLS? It is not even pluginable for a library, so it has to be customized, or unless every OS share the same TLS model. Otherwise, there's nothing that a non-customized toolchain can do.
So one easy thing we could do is get together with the Zephyr guys and you and a number of the vendors in here that do their own tool chains that use NewLib and say, this is the TLS model that we're going to use, and everybody's going to do the same one, right? Because all the ones that are in there have race conditions for most of them. They just minimize the size of the race condition. It's like, that's not really acceptable. How about one without race conditions?
The one in glibc?
Not for bare metal, right?
Okay.
So I have a question. You said libraries. That's a microphone, that should be fine. You said libraries and linker.
Stuff that phones.
No, I know, but so what kind of changes do you need? The linker, that, because we're talking, so you guys have your own.
So I have not done due diligence on this.
That's okay, it's a bot.
But there's a slide on here, I think it's the last one, if you can pull it up.
Oh, yes, but I mean, you know, linkers and even the LOD supports.
The IAR linker has IAR linker scripts, the ARM linker has ARM linker scripts.
That's all plugin.
Yes, and that's a pain.
And they're not, they use different models.
So
There was an interpreter for these things, because it can't be a plugin, because, I mean, if they have different object models, you can't just move things around that don't exist in that model.
Right.
But if you could try to interpret that and move, because if the object files are different, you can't link them together anyway, right? So the object files have to be at least compatible.
sure. So what we did inside TI was, so this is intentionally a bit of an eye chart, right? I took it easy on you guys and I split it into 2 columns. The original author put it all on 1 column so you couldn't possibly read it. But what we're doing inside TI is trying to figure out what we want to do in the future, and his argument is we can't use the bin utils linker and we can't use LLD because they don't support all these features that our linker does. And so that's the estimate of the compiler, the toolchain guy. Now, this list is written by the guy that wrote the TI linker, right? So he's got some investment in these features. I would not say that all these features are critical, but it's interesting that when ARM did their, for their LLVM-based toolchain, they also chose to continue using their own C runtime library and their own linker.
Yes.
To me, that kind of points, I mean, here's at least 2 points that say the LLVM use case, probably better than GCC, but still not there yet.
LOD is not mature yet, so you shouldn't rely on it.
Then again,
Every proprietary toolchain manufacturer's linker has all sorts of, my customer needs this bizarre thing where the linker generates this extra bit here, it does this extra optimization here, and you accumulate this over 10 years, and you've got a huge number of proprietary features that people think, and upstream will probably throw that out. It's not, I think it would be very difficult to get the unified of all linker special features in there. I mean, the one thing is, do you need, if you're talking for an IoT toolchain, again, is the one toolchain standard to rule them all, is that even practical in embedded systems? And
It isn't, and I don't suggest that all these features be supported, right?
Yeah.
But there's going to be some critical ones in here. I mean, ARM arrived at the same decision we did. Part of it is linker file syntax, right? Because nobody wants to write their linker file.
Yeah.
So, but if we did get to, could we go to getting LLD up to snuff so that it's an embedded engineer wouldn't be saying, hey, this is some, yeah.
I think you find kickback from the guys who want to use it for, Linux-like systems. I'm not going to say Linux itself, but there are a lot of people who want their linkers to look exactly like the standard System 5 linker.
Yeah, LLD is, I'll speak loudly, is pretty much based on a drop-in platform model. So there is a Microsoft Windows flavor that can replicate the Microsoft linker, and LLVM still very much sees itself as a platform compiler for sort of major operating systems, and the Linux one is a drop-in interface for GNU LD. I don't suppose it's completely out of the question that it can have emulation modes for other linkers, but just it would be a long time coming, and they'd have to be implemented in such a way that it didn't. Well, I think LLD, just speaking from experience, is its main selling point at the moment, even though it's free, sorry, main user selling point is its speed. We'd find any heavy pushback against anything that made it slower for, say, compiling Mozilla on Linux.
Well, the speed of compilation is important as well, isn't it?
There is a problem
Well,
with C++ and exception and so on.
Yeah.
This is that problem.
But so the other smaller point maybe is that Apple is behind LLVM, and they do care about embedded, not RTOS level, but I mean like those iPod stuff, the M's that they use, M style. No, that's not M.
No.
Yeah, but the M's are like watches and stuff. So they do care about those stuff, and LLD will be an interesting technology. So if we actually start pushing into an IoT LLD framework, that wouldn't be seen as a totally horrendous thing to do. And if we start putting all those things into this framework, rather than messing up in the central part, it should be pretty straightforward to go through it.
It just seems like I would imagine there's a number of companies like TI and ARM that are going through this process now and deciding, okay, we're going to do a whole new generation of compiler, but we're going to stick with our proprietary linker. It seems like such a waste.
And I don't see a problem having even GCC as a more common compiler and LOD as a more common linker. I mean, and the library is not going to be glibc or newlib, it could be something else. It doesn't matter which components you pick, as long as everybody's collaborating on the same component. Then you can make an IoT toolchain, which is a pick and choose from random toolchains.
From the true compiler point of view, TI vastly prefers the LLVM route because we have extra passes we want to put in for security and things like that. So you can have the free one, you can have the TI personality. But from a code point of view, it's the same.
Yeah, it doesn't matter.
So we are almost out of time, so let's do a bit of education. And people who actually do IoT development tell what a day of IoT developer is like. So what tools are used to code, build, test, and debug and analyze IoT systems. So who did this? Who did IoT development?
Yes, I don't know if I want or should explain various features, but I can point one issue I had, for example, and which I would like to be fixed. So when I get a linker map file from GNU LD, it misses static symbols. I would like to be able to pass some option to have it included in map linker file, because I really would like to see all symbols, including static, and have an idea how much every function takes, for example.
File. So this one is file improvement request.
I filed it to GCC backtracker like 2 or 3 years ago, expectedly no reply.
Okay.
Yeah, probably it's not so important for desktop development, etc., but for embedded IoT, it's pretty important. So I'm bringing it up.
Yeah. Okay, so I think from the list, we know what we covered, build. Now, what about testing? IoT, unlike bare metal, likes to communicate, and that implies some hardware involvement instead of emulation. So do we need to develop or do we need to extend any existing tools for testing IoT systems?
Is that this group's job?
It would be. Well, technically, not toolchain, but a larger group, yes.
Okay.
So my primary question here is whether emulation is enough or whether only hardware is enough.
Let's talk to Tyler, that the LTE group that put together the demo. They already have some.
From our side, the main issue that we have is the keying support. We have like a port that supports all the Cortex-M devices, but the key mode that you can easily find available only supports like M3 and all other family. So that is the main blocker that we have. So I don't know if you have someone working on inside.
So I think it's both, because I think you're going to see that in this space, hardware is cheap enough to put on people's desks and so forth. So, you know, for an application developer doing something specific, it's an easy enough thing to do to have a board on their desk, all that kind of stuff. I think there's also needs, as you kind of talk about, you know, network emulation, and when you start talking about having systems with hundreds and thousands of nodes and trying to do stuff, that's going to require simulation type of environments, at least to do some interesting things before you get to kind of hardware testing. So it's going to be a mix of both environments, just depending on what aspect of development you're doing. Yeah.
Scale. So if you have a board in your desk that's $10 and your time, but if you need to test anything, even emulators, you need the whole infrastructure, and that's like millions of hours and dollars and whatever. I mean, the kind of stuff that we're doing in Lava and trying to put boards in the rack, it just takes years. So you may think, oh, it's cheap because it's $10 a board, or it's easy because I put it in my desk and it works. And then when you plug 3 boards at the same time, everything just crashes. So, and making sure that they can be rebooted, they can be accessed, they can be refreshed all automatically, remotely, etc. It's a nightmare.
It's a scale issue, but that same scale issue, if I'm
No, it's not a scale issue. It's a work. I lost the word. It's an engineering issue, because you need to make sure that the power cycle works. You need to make sure that the access works, that rebooting, reflashing, and all remotely. So this is a hard engineering problem to solve.
Yeah, one thing that's, just to give an example, for compiler testing, for correctness, where we're not necessarily interested in getting benchmark numbers, we would typically run a huge battery of tests on simulators. But of course we have to run our benchmarks on real hardware, and that's one way of scaling up your testing massively. So I think you can certainly get developer testing working with hardware, but is IoT going to get to the stage where you're going to want to say, I've got a big compute cluster, how many tests can I actually do? Or is the timing requirement such that, you know, with things like hardware, compilers are fairly deterministic beasts, but something that involves network traffic might not be, and you might need real hardware for that. I don't know what the answer is.
We need to test the system, and that has to be hardware, right? Emulation is great, and our compiler team does a lot of stuff on simulators, but they always run into the bug where the simulator is more forgiving than the hardware, right? So it's even on the tool chain, it's got to be both, right?
Well, at least finish with hardware. You can start with emulators, but you have to finish with hardware. Right?
But you wouldn't believe the number of boards where the only way to reset it is to press a button.
Yes. We know those. We know very well those.
So a couple other type of things, the static analysis tools. So, you know, things like Clockwork or Coverity, we run those regularly in our code base. So having a more accessible tool, most people don't want to pay for those, but you know, so C-Lang's got some. It's not as good as Coverity or Clockwork. So that's another type of tool. code coverage tools, and typically that's hard to do on these little MCUs because you don't have either the bandwidth or the memory to do dynamic code coverage. So how do you do that? One way is to do it with simulation. That's why we're interested in getting QEMU working. Right. And there's, I went to the talk today, they are making progress on updating it. But another thing that we run regularly is, it's hardware oriented, is energy or power measurement. So you make a change to your code, you forget to turn off a GPIO, and all of a sudden you've got a milliamp of current going instead of a microamp type thing. So energy trace, energy measurement type tools are another thing that we regularly use to, because that's very important from a production point of view that you actually meet your energy goals.
And that's harder to do in emulation.
Yeah, can't do it in emulation.
So nowadays, how do you do to measure the power?
We have, TI has tools. We are introducing a new one next week at Embedded World, and it's an inline power supply with very high accuracy power measurement down to microamp, all the way up to hundreds of milliamps. So it'll cover everything from 15.4 to Wi-Fi. So, and then tools to go with that. So then we're doing things in terms of on-chip visibility, so you can actually correlate events on the device. You can see which peripherals are on or off. So then you can actually see an energy trace that's correlated with events in the hardware. First step is just to know how much energy I'm actually using, which is not an easy problem to do.
So one thing no one said, but I'm sure Bill and others, is host-platform support.
So host platform support in this space pretty much means all three, Linux, Windows, Mac OS X, is requirements.
And somewhat related to that is, I know we said let's stop at the IDE level, but a portable build system. So should we look at CMake? ARM tried to do YADA. We've tried to do something, failed miserably. But things like CMake will generate things like Ninja or Make to build directly, but they also have a ability to generate project files. So you could spit out IR Workbench files, or they've spit out Visual Studio project files. But our customers expect to be able to use the IDEs. That doesn't mean you have to necessarily.
That's a good point.
But you could generate a lot of these project files using a meta make description
we could even
tool.
be part of the CMake open sourcing to add additional IDEs, but they already have like things on Microsoft. They have KDE Studio, they have Ninja, Make, some other bits. Right. So yeah, it should be code. What's the code? No, it's not code complete. Anyway.
So.
Putting the hands in building Windows cross compilers and tools is a really new business for Linaro.
Well, we do some of it.
Yeah.
We do Windows hosted tools.
Testing them is much more difficult. Building
Yes.
is not too bad.
Yes.
Testing is even much harder.
So we have covered what ARM's embedded toolchain is today. Here is to
The last comment, because when you want to use tracing tools, and you have several different processors on your SoC, for instance, Cortex-A for Linux, Cortex-M for companion cores, you want to have a system trace which is multiplex. In fact, you don't want to have two different traces generated and that you have to merge and order along the time. You want to have a single system trace ordered in time, and you want to decode it and filter it at developer level, and this requires a kind of something that doesn't exist today. Yeah, if with CoreSight you can do that, but you will use, for instance, ftrace on the Linux side, and on the companion core you need something compatible with that. Yeah, I agree with you. Yeah, CoreSight is the hardware solution, but you also have to have a way to multiplex traces. Okay. So I have a presentation tomorrow about this subject. If people are interested, I think it's the right time to think about that.
Okay, so we'll discuss the tracing question, continue discussing tracing question tomorrow. Here is a slide what Linaro's bare metal toolchain is today. So this is not an embedded toolchain compared to ARMS. This is a bare metal toolchain based on GCC, BNUTLS, NewLib, and GDB for a profile. Now, so far my understanding is that people who want a free embedded toolchain go and use ARM's embedded toolchain, and ARM is providing that. What is interest in this group to sponsor Linaro to add embedded support into our bare metal toolchain? Does anyone have any comments on this?
So MCU guys are very notorious for not liking change. So TI today bundles the ARM embedded toolchain into the CCS for the MCU targets. It even gets used on Cortex-A today, although we're trying to get them to, in those targets. By the way, I'd call your bare metal toolchain an embedded toolchain for Cortex-A. I think the stability story from the ARM team is more aligned with the expectations of the MCU developers, that it's not bleeding edge code that's on its way upstream, and sort of one release a year with stability releases and things like that. It's a little bit, maybe it's just a comfort factor, but I think that methodology aligns with the psyche of the MCU developers a bit more. So I think going forward, we'll probably use that one for M&R, your 32-bit bare metal, and your 32-bit 64 bare metal. There's 3 different compilers for 3 different.
So my personal opinion, and this is not the opinion of TCWG group, not necessarily the opinion of TCWG group, is that it would be very nice for Linaro to pick up, to make our bare metal toolchain compatible and feature compatible with ARM's embedded toolchain, if we have additional resources to do that. So because it makes, Linaro has a quite nice infrastructure for releases, and ARM's, and we are going to continue making our releases anyway. It does not it would be more optimal to have releases for all ARM open source toolchains more or less under the same roof.
But it would bring a lot of confusion. Would it not be better to have the ARM toolchain released through Linaro as it stands at the moment? No, yeah, which it partially is, but is there something that you try to improve there? Because we can work on that. If this is not a technical problem, releasing problem, is that the issue?
I recently heard that ARM takes hosting of this toolchain from Launchpad.net which was kind of net neutral platform for all vendors, and they want to host it themselves. And it makes it kind of yet another vendor compiler, no longer like neutral to all Cortex-M ecosystem. So I guess Linaro wanting to get into this area actually is a good idea.
May I ask why it becomes yet another vendor's compiler? Is even released from our website is neutral to all architectures or MCUs? Yeah, the decision to move away from Launchpad to ondeveloper.com was just to facilitate the download itself, to make sure that the download will be in a better quality. We have a better statistic on the download number source. So there's nothing technical. Yeah.
Just to sense from me as an open source guy, how I consider like representative from maker community.
Right. Okay,
So,
I see your point. So it's less like an open source toolchain if you release from that.
So answering the comment why we should consider improving Linaro's bare metal toolchain to match ARMS is long-term development and maintenance. And I would urge you to think where it is easier to collaborate on embedded toolchain improvements inside Linaro, or trying to ask ARM to do improvements which would benefit most of the community, most of the embedded developers community.
I think in this definition of a toolchain, we are missing pieces, we are missing components, we are missing profiling tools, code coverage tools, tracing tools. This is an incomplete toolchain for a developer.
Do we have that? Do we have those tools in ARMS embedded toolchain?
No, not released today. No. So.
The thread level storage proposal should that be going into NewLib, or is that something that ARM will pick up and put into their embedded toolchain when the group of developers decides this is the way forward? And any of the other libraries.
Toolchain or open source toolchains?
Well, for the open source toolchain.
Yeah, for open source. So I don't think we have a agreement. So this is the first time we heard of this requirement. I think that definitely need some discussion for the community to agree on a solution in terms of a TLS. The one possible way is to build a consistent, build a standard so that everyone uses the same mechanism. Another way might be still leave them as a differentiation, or they do whatever they want. I'm happy to lead the conversation so that people can hopefully make an agreement. I think that's important. But I do have another question regarding to the overall requirement. Looks like the additional requirement to IoT lies in two areas. One is the OS awareness, means different RTOS have different species. Another is the toolchain compatibility. I mean the TI compiler, IR on compiler, or GCC. But the toolchain incompatibility has been there for many years since the traditional embedded development. And
we're not asking GCC to understand IAR's fragments.
So not to that level, but in terms of our linker script, comes to that long list
Today
of
we
linker.
generate 3 different linker scripts, right?
We do that for IAR, and we'll have to do that for testing, for gradings, I don't know how many compilers are used.
At least on the, I've got one thing
It's a
to,
build system and header problem,
Yeah, there's also that, at least I don't know whether it's the same case with TI and IAR, but I'll assume it is, but most linkers and libraries, as in the proprietary ones, collude heavily. There are certain, you can't just, well, the ABI model is you build the object with the same header files all the way through, or that you build the header files from the compiler that you use, but you use the system libraries that are associated with the linker. Any compatibility beyond that is outside the scope of the ABI, because it was seen that most libraries...
No, not EA ABI. You're supposed to be able to take anybody's...
No, it's not quite that. I've got a talk on this tomorrow. It's it's actually not a design goal to be complete any object with a complete mix and match.
Oh, yeah.
But anyway, I might be best talking about that tomorrow.
Yeah. Oh, there's a
Okay.
ABI.
It's evidently good enough that he hasn't detected
It's not saying it can't happen. It's just what the compatibility model was when it was invented.
The ABI allows for a lot of leeway for vendors, and they have the right to not be compatible if they don't want to.
Yeah.
So for ARH32, we tried to define a C library ABI, and essentially it failed entirely because nobody was prepared to sign up to the restrictions, and nobody will agree even on the basics like whether certain of the standard types are fundamentally unsigned ints or unsigned longs or ints, all of which are the same size, but none of which are compatible. And as soon as you get to C++, those things are seriously important.
enums and ychars are notorious.
That's another one.
Yeah.
Okay, so we're wrapping this up. Thank you, everyone, and we'll see you tomorrow.